Hi my dear friends, welcome back to PULLAS Academy. This is Kiran Kumar, Faculty of Physics. This is Physics class for ECET students. Today we are going to discuss about the one revision class on kinematics. Okay, so in this video we will discuss all repeated models in the ECET exam. Clear? Right. So first we will let us discuss about kinematics. Actually kinematics is one of the topic in the mechanics. In this topic mainly discuss about the study of the motion without cause of motion is called as kinematics. That means the study about the motion of an object without cause of motion is called as kinematics. That's all. ఓకేనా, అంటే ఇక్కడ ఈ టాపిక్లో మోషన్లో ఉన్నటువంటి ఆబ్జెక్ట్స్ గురించి డిస్కస్ చేస్తాం, కానీ మోషన్కు కారణమైనటువంటి ఫోర్స్ గురించి మనం డిస్కస్ చేయమమ్మ. ఫోర్స్ గురించి కాకుండా ఓన్లీ మోషన్లో ఉన్నటువంటి ఆబ్జెక్ట్స్ గురించి కైనమెటిక్స్లో డిస్కస్ చేయడం జరుగుతుందమ్మా. ఓకేనా, సో వీ విల్ డిస్కస్ క్లియర్లీ అమ్మ. దిస్ ఇస్ నెక్స్ట్. సో హియర్ ఇన్ దిస్ టాపిక్ అమ్మ, యాక్చువల్లీ వీ హ్యావ్ ద సిలబస్. ఫస్ట్ వీ విల్ డిస్కస్ కైనమెటిక్ ఈక్వేషన్స్ అమ్మ. ఓకేనా, ఫర్ యాక్సిలరేటెడ్ బాడీ. నెక్స్ట్ ఆఫ్టర్ దట్ వీ విల్ డిస్కస్ కైనమెటిక్ ఈక్వేషన్స్ ఫర్ accelerated due to gravity. Okay, next after that we will discuss body projected from the tower. Okay, next we will discuss horizontal and oblique projectiles. So here related some applications also we will discuss. That's the syllabus for kinematics. Clear? Right, first we will discuss in the kinematics. First you need to understand some parameters. After that, based on the relation among these all parameters are represented by simple equations, they are kinematic equations. So before that kinematic equation you need to understand this all parameters. The first one of the important parameter is distance. What is distance? Distance nothing but path length. So according to the definition, distance stands for total length of the path traveled by the body. Total length of the path traveled by body is called as distance. That's all. Okay, now next, distance is a scalar quantity. It has only magnitude, there is no direction. It is nothing but length. That's why its unit says meter. Okay, its dimension formula is L. Okay, next one is displacement. The next parameter is what? Displacement. Displacement nothing but S bar. That means the shortest distance between two positions, initial and final position, is called as displacement. This is the shortest distance. The straight line shortest distance is called as displacement. Simple definition is displacement is the shortest distance. Okay, shortest distance between 2 points is called as that is indicates what so it has magnitude and direction also in a specified direction, in a straight line direction. What is the distance traveled by the body's displacement? So what is here also units is similar to meter. It's nothing but length. That's why dimension formula is L. It is a vector quantity. One important relation between distance always greater than or equal displacement. Okay, now that is distance always measures positively. Displacement may be positive, may be negative, may be zero. Next one more speed. Next one, speed stands for distance by time is called speed. So these two are scalars. That's a speed also scalar. Next velocity. What is velocity? Velocity stands displacement by time. Displacement by time is called as velocity. That's all. Okay, now so in this way you need to understand. Next one, so before this parameter, one more parameter, that is average speed and average velocity. Average speed or average velocity. What is average speed? Average speed stands total distance traveled by the body. Total distance traveled by body by total time. That is called as average speed. What is average velocity? average velocity stands total displacement by average velocity v bar is equal total displacement by total time. Just simple definition is total displacement by total time. So this expression stands average velocity. Clear? So next one more. Suppose if an object is in uniform motion, so here there is no required to measure acceleration. If the body is in non-uniform motion, what is difference between uniform motion and non-uniform motion? If the velocity of the body changes with time, that is non-uniform motion. If the velocity is remains same throughout the motion at any point, that is called as uniform motion. Suppose if it is in non-uniform motion, how to variate its velocity? If you want to understand, define one more quantity, that is acceleration. What is acceleration? According to the definition, the rate of change of velocity is called acceleration. Acceleration is equal to change in velocity by time. So change in velocity, u is the initial velocity, v is the final velocity, v minus u is the change in velocity by time. So this expression stands acceleration. Okay. Next, here in the units of acceleration is what? Meter per second by second. That means meter per second square is the units of acceleration. Its dimensional formula is L t power minus. It is a vector. It is a what? Vector. This is about the acceleration. Clear? Distance, displacement, speed, velocity, average velocity, acceleration. Okay, if any object is in acceleration, its velocity changes with time. Okay. Okay. So now we are going to discuss kinematic equations. Kinematic equation, we have four kinematic equations. The first kinematic equation is v is equal to u plus area. This is first kinematic. So if in the given data u, v, t, use the first kinematic equation. If asking velocity of the body in a total given time, use this formula. That's all. Okay. Next, second kinematic equation, s is equal to ut plus half at square. If asking displacement in a given total time, use this equation. If asking displacement in a given total time, use this formula. Next, third equation, so v square minus u square is equal to as. This is also final velocity of the body in terms of displacement. In the given data uv s, acceleration is common any question. So if given uv s in the given data, use this one. In the given data uv t and acceleration is common, then use first kinematic equation. That's the difference. With this equation, velocity equation, it is also velocity in terms of displacement in terms of time. That's all. If asking displacement in a given total time, use this one. If asking displacement in a nth seconds time, the formula is Sn is equal to u plus a by 2 into 2n minus 1. So this equation stands what? Displacement of a body in the nth second. So this is called as Sn. So in this way, we in the nth second means at a particular time, if asking displacement, use this equation. This 4 is called as what? Kinematic equations. What are the kinematic equations? 1, 2, 3, 4. So these are called as kinematic equations. Clear? Right. Next, so after that, here we will discuss here acceleration due to gravity. What we discuss? Acceleration due to gravity. What is acceleration due to gravity? So it is denoted by small. The uniform acceleration getting by the body due to the gravitational force is called acceleration due to gravity. So due to the so based on the acceleration due to gravity, we will discuss vertical motion. Okay, now we will discuss vertical motion. This is in horizontal motion, use this kinematic equation. If in vertical motion, simply is called as this is horizontal motion. In horizontal motion, use this equation. In vertical motion, that is based on the acceleration due to vertical motion. Okay, now. So along vertical motion, so we have two types of vertical motions. One is freely falling body. First one is freely falling body. What is freely falling body? Actually, freely falling body stands for a body is dropped from certain height that is called as freely falling body. Without any force is applied due to the gravitational force, it is moves towards the ground, that is freely falling body. For freely falling body, what are the known values? Initial velocity is 0, acceleration is called plus g, okay, now displacement is called h, it is dropped from certain height h, then taken time is tm, so velocity v is called vm. These are the known values. So if you want kinematic equations, here asking question kinematic equations for freely falling body. Okay, now what is the first kinematic equation for freely falling body? This is expression, v is equal u plus at. But here v is equal substitute v, u is equal substitute g, a is equal substitute g. So then v is equal gt. This is the first kinematic equation for freely falling. Next, second kinematic equation, s is equal to ut plus half at square. This is the formula. So here h is equal to u is 0, 0 into t plus half gt square is the formula. Based on this equation, h is equal to half gt square. So this equation stands for second kinematic equation. That's all. Next, third kinematic equation, that is actual equation v square minus u square is equal to 2as. So here v is equal to vm, u is equal to 0, 0 square means 0, 2 into a is equal to g, s is equal to h. That means v square is equal to under root of 2gh. So v is equal to under root 2gh, or v square is equal to 2gh. This is third kinematic equation for freely falling. So for fourth kinematic equation, in the same way, actual formula Sn is equal to u plus a by 2 into 2n minus 1. Okay, u is equal to 0, a is equal to g by 2 into 2n minus 1. That means hn is equal to here. What is formula? This is the formula, g by 2 into 2n minus 1. That formula indicates the hn. So these are the kinematic equations for freely falling body. Okay, now we will discuss kinematic equations for upwards projected body. Okay, now we will discuss vertically upwards projected body. Okay, it is also along vertical line, that's why this is vertical motion. When you projected vertically upwards, this is ground, one body is projected upwards, then it is moves along this vertical straight line and its velocity becomes 0. This displacement s is equal to hm, so its velocity u, and its acceleration while moving upwards velocity decreases, that is minus g. So these are the values for this upwards projected body. U is equal to u, v is equal to 0, a is equal to minus g, and s is equal to hm. So these all are the substitute in the equation. Then time t is equal to t. From the first kinematic equation, if you substitute, where v is equal to 0 is equal to u minus a is equal to minus g, that means u is equal to gt. When it is reaches to the maximum height, this is the formula. Okay, so otherwise here this is first kinematic equation. If you substitute in the formula second equation, this is the first kinematic equation. Second kinematic equation, h is equal to ut, a is equal to minus minus g means minus half. This is second kinematic equation. Third equation, v is equal to 0 square means 0 minus u square is equal minus 2gh. That means finally u square is equal 2gh. This is third kinematic equation for upwards projected body when body reaches to the maximum height. Next one, so fourth one is I consider hn is equal, what is formula? U is equal not 0 here, u, a is equal minus g by 2 into 2n minus 1. This is fourth kinematic equation. So for example, this is if you consider maximum height in all equations where h is equal to substitute capital H. Just that's the simple difference. Okay, so this is about the kinematic equations. Otherwise, here, so these are kinematic equations 1, 2, 3, 4 for freely falling body, for upwards projected body when it reaches to the maximum height. Otherwise, if it does not reaches to the maximum height, it is reaches to certain height small h. In this case, the kinematic equations are, so you need to understand these kinematic equations where, so here in this equation where this one is, first one is same, v is equal, first one is what, u minus j. This is first kinematic. Next what, h, small h is equal to ut minus of gt square. Next, this is second, when reaches to certain height h, when while projected upwards. Next third equation v is not 0 when it is reaches to the maximum height, velocity 0. Otherwise at a particular instant of position, that is v square minus u square is equal 2 into minus g into small h. That's the formula. Next hn is equal to u minus this is g by 2 into 2n minus 1. So these are the four kinematic equations for vertically upwards projected body. Okay, these are the kinematic equations for upwards projected body and freely falling body. Okay. Okay, now we are going to discuss some applications or some important parameters related to the upwards projected body, freely falling body. So the first one of the parameter is maximum height. Maximum height. What is maximum height? That is denoted by h max. So for upwards projected body, that means when you consider one body, it is projected upwards with velocity u, it reaches to the maximum height. This s is equal to, I consider capital H. So here asking capital H, that formula is u square by 2g. So this expression stands maximum. Maximum height formula is what? U square by 2g. That is maximum. Next one, so if asking time of ascent, time of ascent. What is time of ascent? That is denoted by t. So when you project upwards with velocity u, the time of ascent t is equal to u by h. That's next. This is one more. So when you projected upwards with u velocity, this is a formula. Okay, now one more. So for freely falling body, taken time to reach the ground, that is time of descent. So you need to remember the formula, time of descent. What is time of descent formula? That is td is equal, after simplification you get td is equal to under root of 2h by g is the formula. But here this td and ta is same okay, now if it is coming, it is dropped from the same certain height, ta td are same. Otherwise it is dropped from another height, this ta td is not same. If it is coming from the same height after projected any body, so then the taken time to reach the same height, from the same height reaches to the ground, it takes the same time. That is the point. Next one more, time of flight. One more related part. What is time of flight? The total taken time to reach the ground after projected upwards. This total taken time actually time of ascent plus time of descent. Time of ascent is u by g. Time of descent also similar to u by g. So then totally 2u by g. This is time of flight. Clear? So these are the important formulas. And one more, when you projected with velocity u reaches to height h, so then u is equal to under root of 2z h. If you consider small h or capital H, then write here capital H, or small h, small h. Okay, so this is a velocity upward, this is initial velocity of the upward product. When you drop it from height h, what is the striking velocity of this freely falling body? That is under root of 2z h. These two are the same. Okay, if it is comes from the same height, when striking on the ground with the same velocity. Okay, so these all are the related parameters to the upwards projected body and freely falling body. Okay, clear? Okay, now we are going to discuss motion of a body projected from the top of the tower. Actually, we have mainly two important concepts are completed. One is kinematic equations for uniformly accelerated body. We have four equations. V is equal to u plus at, s is equal to ut plus half at square, v square minus u square is equal to 2as, and sn is equal to u plus a by 2 into 2n minus 1. That's the formulas, very important equations. Some question is repeated based on that equations, but which formula when we use is very important. Okay, na epudu use cheyalani kuda cheppanu maniku. Okay na, so velocity adiginamma, total time ichesi velocity adiginam first kinematic equation. Leda in the given data uvt is given, then use first kind. In the given data uvs is given, third kinematic equation. That's the fine. So final velocity of the body is asking in terms of time, first kinematic. In terms of displacement, third equation. If displacement is asking in a total given time, second equation. Displacement of the same body at a particular instant of time, use the fourth kind. That's the importance. Just this is first. The second concept, just for freely falling body and upwards projected body. What are the kinematic equations for freely falling body, amma? Okay, now asking here. So what are the first, second, third, fourth kinematic equations for freely falling body, upwards projected body? That's just substitute that values, then you get it, amma. Here important is some parameters, amma. What is the expression for maximum height of upwards projected body? Time of ascent, time of descent, time of flight. Okay, next, what is velocity, striking velocity of the freely falling body, or project initial velocity of the upwards projected body? That's the important topics in these two concepts. Now, for example, this is one tower, suppose this is one tower. From this tower, one body is projected with velocity. This is one body projected with velocity u. Then it reaches to some more height, and finally reaches to the ground. In this way, it is moving and finally reaches to the ground. The height of the tower is capital H. Okay, when you project it like this. Okay, so then what is the height of the tower? If sometimes is asking. So here projected with velocity u. Okay, it is projected with velocity u. So in this case, here what is from the second kind? So what is total displacement? It is, suppose, reaches to height small h. The displacement. So while moving upwards, that is plus h. While moving downwards, minus h. Next, while reaches to the ground, minus h. Total is minus small h. So then totally minus capital H. Displacement. It is projected upwards. That means initial velocity u. It is projected upwards. That means a is equal minus a. Okay. So next, what is the this taken time? I consider Tm. Okay. If you use the second kinematic equation, S is equal to ut plus of at square is the formula. S is equal minus h is equal to ut. A is equal minus the minus of gt square. So from this formula, capital H is equal to minus ut plus of gt square. So this formula indicates the height of the tower. What is the height of the tower? Minus ut plus of gt square. So this is called as the height of that formula is important. Sometimes asking here, time is asking, sometimes h is given and u is giving, asking time. Sometimes here t is giving, u is giving, h is asking, anything is asking, you have to find. When it is projected upwards from the tower, otherwise from the same tower, so if it is projected horizontally with some velocity u, when it is projected horizontal with velocity u, ux is equal to u, but uy is 0, that means it is similar to the freely falling body. That's why after simplification, height of the tower formula is just half gt square. That's for freely falling body also same. Just to remind these equations. That's it. For freely falling body, same formula. When you projected horizontally and when you projected upwards with velocity u, this is the height of the tower form. So this is concept 3 and related expressions. Just concentrate. This is the most important formula. 90% question is asking based on this is minus ut. Remember this point, don't confuse. Clear? Okay. Right. We will discuss fourth concept, most important repeated model, projectile motion. Actually, what is projectile? Actually, if any object is projected into air at an angle theta with the horizontal, that is called as oblique projectile. If any object is projected horizontally from certain height, that is horizontal projectile. We have two types of projectiles. First, we will discuss oblique projectile. Oblique projectile. It's the most important application. Important repeated model. Oblique projectile. Right. What is oblique projectile? Suppose if this diagram is very important. This x-axis is horizontal direction. Y-axis is vertical direction. When any object is projected with velocity u, so at an angle theta with the horizontal, when you project it, then it is moves along the parabola and reaches to the ground. That's all. This is called as oblique projectile. When any object is projected at an angle theta with the horizontal with velocity u into a, so that is moving along the parabola. That's why it is called projectile. That's all. So its velocity is not known direction. It is divided in two components. One component is u cos theta, horizontal component. Second component along vertical direction, that is uy is equal u sin theta. This is ux, this is uy. Okay, so for at the initial point, what is velocity? U bar is equal to ux cos theta into I cap plus u sin theta into j cap. That's all. Clear? Next, acceleration a is equal, ax is equal, along horizontal direction its motion is uniform, along vertical direction it is moving upwards, acceleration gravitational force acting downwards, that's why we consider minus h. Okay, now so next at this point, this is acceleration direction, this is velocity. What is angle between 90? So plus theta is the angle between velocity and acceleration. Okay, so this is at the initial point. Okay, if you consider one more instant of point, so this at the instant of point velocity vm. Suppose if you want velocity here, it is divided in two components. One is vx, one more is vy. What is vx when it reaches to certain point p? The taken time is tm. At t taken time, so velocity, horizontal direction velocity is not changed, that is always u cos theta. Vertical velocity is changes, that is here u sin theta, but from the first kinematic equation u sin theta minus gt. This is the formula for velocity. Velocity is gradually decreases while moving upwards for oblique projectile. That's so. What is displacement when it is reaches to this point along horizontal direction? This is the displacement, that is x. X is equal to u cos theta into t is the formula. Next, along vertical direction displacement is ym. Y is equal to, how can you measure this displacement? From the kinematic equation. So that is after simplification you get u sin theta into t minus of gt square. That's the formula. Okay. So from this equation t is equal to x by u cos theta. Substitute in this equation and simplify. After simplifying, u sin theta into, so t is equal to what? X by u cos theta. Next, minus of g into, so t is equal to what? X square by u square cos square theta is the formula. So now u cancel, sin theta by cos theta is tan theta into x minus g by 2u square cos square theta into x square. This is called as a displacement of this projectile. Here tan theta, a is equal to tan theta, sometimes asking from this formula. So where b is equal to g by 2u square cos square theta. If you substitute this in the expression, y is equal to ax minus bx square. This is parabola equation. So this parabola, from this parabola equation understood, so the trajectory of the oblique projectile is parabola. So these are the important expressions. Next, when it is reaches to the maximum height, its velocity vx is equal u cos theta. But here along vertical direction, vertical component of velocity is 0 at maximum height. Very important point. So for oblique projectile at maximum height, velocity is 0. It is only horizontal velocity. The total velocity is equal to also u cos theta. That means at maximum height, its velocity becomes minimum, not 0, but vertical component of velocity becomes 0. Okay, now in this case, this is acceleration, this is velocity. The angle between velocity and acceleration only 90 degrees. That's all. For example, at another instant of position, this is velocity. So now again divided into component, it is inclined, that is Vx and Vy. What is difference? Vx is always same at any point, because along horizontal direction its motion is uniform. Here also you can. But along vertical direction Vy is equal, what is formula? U sin theta. Not here for Vy is equal minus gt, but here when while moving downwards A is equal plus gm. That means here u sin theta plus gt is the formula. That's all. That is the difference between these two. This is velocity, this is acceleration. 90 minus theta is the acceleration. That angle between velocity and acceleration. Okay, now when its striking point also same here and here, same to same. So these all are the parameters related to the oblique projectile. While moving on the traveling path, how to vary its velocity, acceleration and displacements based on this concept very easily understand. Okay, we will discuss for this oblique projectile what is maximum height equation, what is range equation, okay. So what is time of ascent, time of flight, time of descent, these expressions we will discuss, okay.